Thank you everyone for joining us for the impact theory of dinosaur extinction with Jesse Mason. Jesse has been an astronomy geek since Hale-Bopp, the great comet, and he has a double major in physics and music, an odd combination if you ask me, at EMU, and he returned there for his master's degree in physics. And he directs the Farmington Community Stargazers Club, runs the physics and astronomy labs at Oakland Community College. And he's taught astronomy, college astronomy, and physics courses since 2008 from EMU, Henry Ford, and Schoolcraft College. And he runs the Teach Me YouTube channel where he teaches physics problem solving to millions of physics students. I've seen some of his stuff. It is way cool and fun to look at and educational. And knowing him, I can tell you that he really has the gift of teaching. So I'm going to throw it to Jesse to take off and talk about It Came from Space.
Thank you very much, Brian. My name is Jesse Mason. I, as Brian said, am a college physics and astronomy teacher. I also run a local astronomy club that hosts monthly star parties, or hosted monthly star parties until COVID, out of Heritage Park in Farmington. And most importantly, for this talk, my favorite dinosaur is the Triceratops. And someone killed my favorite dinosaur, along with 3 out of 4 creatures 66 million years ago. We bid them farewell, and for centuries, for over a century at least, we didn't really have much of a clue of why they disappeared, which is forgivable because it really took us 2 million years to find out they existed. In the 1800s, a gentleman by the name of Richard Owens declared that there must have been some kind of new creature that we did not know about, which he termed the dinosaur, based on some discoveries that were made in the previous decades. William Buckland had discovered a part of a jaw, which later was described as some sort of megalosaurus creature, thought to be some kind of aquatic reptile or lizard we hadn't discovered yet. The size was extremely large. And then, of course, Gideon Mantell discovered parts of an iguanodon. And when Richard Owens described this extremely ferocious new kind of creature that we hadn't heard, it didn't really settle in to the public consciousness until some miners found some bones in a mine shaft in Denmark that turned out to be over a dozen complete skeletons of these iguanodons that Mantell had found just parts of. And then dinosaurs became part of the biological lexicon rather quickly, and we found new species, it seemed, with every decade. My favorite dinosaur, the Triceratops, was discovered in the 1880s in Colorado by a man named George Lyman Cannon. He brought it to some scientists who thought maybe it was some sort of overly large bison, prehistoric bison, but shortly after a couple other skeletons were found, fossils were found, they were recognized to be a new species of dinosaur. They named it the Triceratops because of the horns. Of course, this is not a picture of the first Triceratops. This is actually a picture of a college student last year that went on a hunting expedition in North Dakota with a professor of, I think, paleontology or something like that, and they discovered a Triceratops skull. So that's a fun way to spend a summer if you're a college student. Here's some scientists playing around in Michigan. My good friend Samer Hariri, a very talented geologist, took me on an expedition through Fitzgerald Park, and if you've never been there, I can't recommend it enough. The outcropping of rocks is just breathtaking. And the story that I'm telling today is kind of a murder mystery, but it's told by rocks. And the way it works is the deeper you dig with rocks, the older those rocks are. And the farther back you're looking into history. And so this part of this rock outcropping in Fitzgerald Park is actually some of the youngest rock in Michigan, but you can see layers and layers of it. And you can see a dark band in the middle there. And that's a layer of coal that was formed about 300 million years ago when Michigan was kind of a swamp. We have names for the various periods and eras that we can dig down into. When we dig into the earth, as I said, we dig deeper, we dig further and further back into history. And the story I'm telling you today is the story that occurred between the layer on the left that says T and K. T stands for Tertiary, that is one era, and the K stands for Cretaceous. And the line between them is the line that separates not only the two eras, but it separates the existence of the dinosaurs and the extinction of the dinosaurs. A physicist and a geologist, much like you saw in the last picture, but a little more notable, in 1980 made a discovery on that layer between the Cretaceous and the Tertiary periods, where the dinosaurs went extinct. The thin layer of clay in between the two, which is pictured on the right a little more clearly than on the left, they made a discovery about that layer of clay. Now, this layer between the Tertiary and the Cretaceous can be seen in most places around the world. You won't see it in Michigan. We don't have rocks that young in Michigan. But this layer had something that piqued their interest. Now, the guy on the left, his name is Luis Alvarez, Nobel Prize-winning physicist. The guy on the right, his name is Walter Alvarez. That's his son, and he's the geologist. And what they discovered, along with some chemists who ran some tests on that layer between the two, is that boundary, that thin layer of clay between the Tertiary and Cretaceous, had a spike in iridium levels. Iridium was not expected to be seen in that layer. Now, to understand why, let me tell you a little about iridium and our planet. If you layer oil and water and various other dense substances, they will form this strata. They will stratify. And as you can see in the picture there on the left, you can float some things on there. When our planet was forming, iridium, which is on the right there, this heavy metal sank deep into Earth's interior. So you don't see a lot of iridium in the crust. So why did Luis and Walter Alvarez detect this spike in iridium? What could explain the sudden arrival of iridium on our planet's crust? Their best guess is from celestial bodies that didn't undergo this differentiation process, namely asteroids. Asteroids aren't typically big enough to even be respectably round. They're usually odd-shaped, so the iridium doesn't sink into the middle. And when they smash into another celestial body, they will send bits of themselves, including that iridium, all over the impact zone, and if it's hard enough, across the entire celestial body. And that discovery led to the theory that an asteroid was responsible for wiping out the dinosaurs. The iridium layer between the Cretaceous period and Tertiary period, or the Cretaceous layer and Tertiary layer. Now let's take a look at what we would be looking for, of course. We want to know what the impact looks like. Impacts typically look like this when there is an asteroid or a large meteor strike on a body. You have this depression, and you have these melting episodes that even changes the composition of rocks that don't melt. They change the density in such a way that we call them shocked.
Good night, Daddy.
Good night, Henry.
Daddy, I have a crack in my tooth.
Oh. He's got a tooth coming out. You're going to have a crater in your mouth. I'm telling people about craters right now. So this crater will also shoot out bits and pieces of not only the asteroid, but the surface of the body that's being struck. And if you want to see what this looks like, you don't need to look much further than your backyard. When you look at the moon, when you look up at the moon, if you have a pair of binoculars, you can actually see craters with your bare eyes, or I should say with your aided eyes. And if you look at the bottom where this enormous crater appears, it's called the Tycho crater, you can see ejecta. Just with a pair of binoculars, you can see this bits and pieces being thrown across nearly the entire moon. That crater is about 50 miles across, and I would say it's roughly the size of Michigan's thumb. Now, before we get on to our crater hunt, we have to ask, what makes a theory versus a hypothesis? A hypothesis is just an explanation, but a theory is an explanation that explains a broad range of observations. And what we're going to cover next is other pieces of evidence besides this KT boundary that supports this idea that an asteroid struck the planet. But before we move on, Brian, are there any questions yet?
I don't see any questions yet. We've got a lot of enthusiastic watchers, but I have a question.
Shoot.
When I saw a special on this, what amazed me was that once this object came and slammed through the atmosphere and hit the Earth, it blasted particles back out through the hole it just made in the atmosphere and into space. Is that right?
That's what we think.
Wow.
It has to be an incredibly energetic impact to do something like that. And we'll talk about exactly how big we think it was in just a moment. It was big enough when it slammed into the Earth that, as I said before, that it was able to shock what we call quartz, and change the density of it enough to be detected. It doesn't melt the quartz. Quartz has a very high melting temperature, but there are parts of this impact zone that we've detected that have quartz that's been altered by this energetic impact. The only other time we've seen anything like this is surrounding a nuclear blast. It takes an immense amount of energy to create this kind of phenomenon in quartz. What other kind of evidence have we seen?
We do have a couple questions that came in about about craters.
Yeah.
Carrie wants to know, why do the craters in the moon have these rays coming out from them?
Because when that... let's back up a few slides. When that asteroid or that meteor strikes the surface with such immense speed, it throws out bits and pieces of the moon, as well as the impactor itself. It gets broken apart and thrown all over the surface.
Wow, and the other question is, did the impact of the craters affect the moon's orbit? Christopher wants to know that, if the craters affected the moon's orbit.
It would have to have some impact on the orbit, pardon the pun, but I would say negligible impact on the orbit.
Okay, that's it for now.
Okay. So what other pieces of evidence did we see? We saw these things called glass spherules, which are bits and pieces of rock that were melted up and thrown into space, maybe even vaporized, thrown into space, and then they crystallize. And as they fall back to the planet, they fall back almost like raindrops, only they're made of liquid rock, or by the time it gets to the surface, solid rock. These glass spherules were detected along with shock quartz. Glass spherules and tektites, that is, little bits of Earth's surface that's been broken apart and strewn across this impact zone, have been detected. And I found one last night that I could buy for $100. So I shelled out to $100 so I could have a little bit of my KT boundary for myself. And even this sample of tektites, as you can see, has some glass spherules in it. Now, these are pieces of evidence, but we're still missing the smoking gun. And it turns out that the same time that the Alvarez team was developing their idea in recovering spherules and tektites, A geologist for an oil company in Mexico had done a survey, a special type of survey, and he detected an underwater and underland structure off the coast of the Yucatan, or really at the line, the coast of the Yucatan Peninsula in Mexico. Now, he didn't release this information because it was proprietary to Pemex, the oil company, but eventually it did get out there and it matched what they were looking for. This is our best guess as to how and where the extinction of the dinosaurs and 75% of all living species occurred. This impact zone is roughly the size of up north. This crater, if you look at the rim of the crater, that semicircular arc there on the bottom, it's about the size of the upper part of the lower peninsula. And if you look at those little white dots, there's even more evidence for this impact zone. The little white dots represent these little pools called cenotes that are detected, or I should say are present, in Mexico. And some of them had sacred significance to the Mayans. This one is at the Chichen Itza complex. These cenotes, these little areas of low density, are thought to have some evidence, or the evidence of the impact that created this rim, this ring. Now, we're still doing research on this stuff, and as recent as 2016, we drilled into the ring of the Chicxulub crater, named for the town Chicxulub where this crater exists. I should say where it is present. It's not very detectable in thick forest and out in the ocean. But shortly, or I should say just beyond the coastal boundary, they drilled into the outer ring, and what they detected, as you see in this picture on the right, what they found was granite. Lots of granite, which shouldn't be on a seafloor bed. Granite is something that we believe is mostly deep in Earth's crust. So why is it there? Well, the thought is that this impact brought up stuff from deep in the Earth's crust and sent it into the rings. It's back to this picture that I showed you of the impact site. It throws up bits of the low crust and brings it to the surface. Additionally, this kind of granite, if you're familiar with granite, is different than the kind that you would see in a quarry because the crystals are so big, which means that the crystals cooled very slowly deep in the Earth's crust when they were formed. So these are the bits of evidence that have convinced us that an asteroid wiped out the dinosaurs. Before I go on, are there any more questions, Brian?
We've got a couple more. We've got Summer Hariri asks, so there could be Terran meteorites on the moon? He thought that would be very cool.
I don't see meteorites from perhaps extremely large impacts. Sure, I think that's possible.
And Dejo Deward asks, what was the most recent crater formed on the moon?
That I don't know. I'm sure we've had one in the last 2 million years, but I'm not sure. Yeah. It depends on the size of the crater.
Yeah,
you could have a crater that's you could have a micro crater, a crater that's just 10 meters across, and that could have happened last week. In fact, we observed an impact on the moon just in the past few years, and that certainly left a crater. So I guess we know of one a few years ago.
And lastly, a question from Ken. When that big explosion happened due to that space rock, how many of the sea creatures are said to have perished?
My understanding is the same percentage.
Wow.
And let me explain why we think this happened as well, with regard to the sea creatures, because, let me get there. So, let me give you the picture of what this impact how it went about, as far as we can tell, or as far as we can predict from our understanding of it. The size of the impact, according to the Alvarez team, who used the iridium concentration levels to estimate the size of the impactor, they suggested it was 10 kilometers wide, about 6 miles wide, and that it was moving at 40 times the speed of sound. It burst through the atmosphere absolutely suddenly, catching all of the creatures unawares. And I would suggest it was a Thursday, because I'm a Hitchhiker's fan. It's a Thursday, May 25th, 66 million years ago. Dinosaurs are minding their own business. And in the Mexico area, an asteroid 10 kilometers wide, moving 40 times the speed of sound, hits the ground. Blinding flash of light, launching debris and a dust plume into space and into the stratosphere, causing an air blast like you would see in a nuclear explosion that reached for thousands of miles, leveling forests for thousands of miles. A heat blast that followed, just scorching the surrounding 500,000 miles. Mexico, what was left of Mexico at that time, was set ablaze. Now we've seen an air blast that leveled a city. This is Hiroshima. Our best estimate is that the dinosaur killer was 1 billion Hiroshimas. Following that air blast, tsunamis ensued. Tsunamis consumed the nearby coastlines, and then it began to rain. Within a few minutes, those vaporized bits of rock congealed into red-hot, I call it lava rain, they're those spherules, and they began to pepper the planet. And as they blazed through the atmosphere, red hot, they raised the temperature of the atmosphere, they raised the temperature of the air so much that spontaneous combustion occurred in the surrounding area. Roughly, the entire hemisphere burst into fire. Wildfires consuming the landscape, and in the coming days, an unusual rain. Where this asteroid struck was a very unfortunate place for the dinosaurs and all the life on Earth at that time, because it had a very high concentration of a type of rock called anhydrite, which has lots of sulfur, which peppered the air with sulfur, combining with water to make sulfuric acid. This acid rain poured down onto the planet, spoiling vegetation, ruining water supplies, and altering the ecosystem for millennia. If that's not bad enough, the dust plume consumed the entire planet for a solid year. There was no sunlight at all. It was midnight for an entire year. This is what a dust storm looks like on Mars. Imagine a dust storm that turns our planet dark brown. That's what it was like. The dinosaurs that survived those first couple days would face the worst conditions for millions and millions of years. Because when you take the sun away, you cause a complexity collapse in the food chain. And that's what we saw. First, the plants and the plankton and the waters, and then the plant eaters, and then the eaters of the plant eaters. It became a Darwinian battle that lasted for thousands, 10,000s, hundreds of thousands, perhaps even 1 million years, which is how we lost my beloved Triceratops. It's not likely that a T-Rex would square off with something like a Triceratops, but we know it happened at least once, because we discovered T-Rex teeth marks in a Triceratops skull. And it's possible that in a starvation situation, that a T-Rex would risk it all to try to take a Triceratops out. One animal did pretty well, or one type of animal, and that is the mammal, especially small mammals, that could hide relatively easily, that could get around at night, that had a very flexible diet, and that reproduced very well. These animals, as you know, would go on to evolve to become thinking animals, reasoning animals, masters of fire, and conquerors of the stars. We didn't leave all of the dinosaurs behind that day. Some of the theropods survived and would go on to become those beautiful things we hear outside in the morning. Brian, are there any questions for me?
Oh, we've got 3 questions I see here.
Okay.
Mary asks, if the asteroid were to move slower, what would be the response be to its impact?
If it weren't moving as fast, I would say it wouldn't be as devastating. It wouldn't have been as devastating. And if it was slow enough, maybe it wouldn't have thrown up all of that anhydrite, vaporizing it into the atmosphere and causing all this acidic rain that spoils the water supply and acidifies the ocean, changing that ecosystem for millions of years.
All right. And Christopher asks, how prominently can we see the impact that the crater left on the area today through land formations?
You cannot see it at all, which is why we never discovered it. You can see the CENOTES if you go. There's a ring of them, but that's the only thing you can really see with your eyes. We needed scientific tools, I think magnetometers and gravitometers, to detect this variation in density.
Harmony Smurf asks, what was the size of that tsunami? How tall was the tsunami?
The tsunami wasn't as tall as you'd think, but mostly because it slammed into a part of the planet that had relatively shallow oceans. So it was only a couple hundred meters tall. Only. It was a very, very large tsunami.
Brianna thinks that there's something predicted for October of 2020.
An impact for October 2020?
I don't know. It says.
I hope not.
Is there a tsunami predicted for October? Is there something?
Not that I know of.
Okay.
I don't know that we can predict those things beyond maybe a few minutes or a few hours. But keep a lookout. I want to finish off by asking a couple questions like, will we go out with a bang like the dinosaurs did? Is that threat gone? And this amazing image, these pair of images, are of a comet that was discovered by a gentleman that was presenting earlier tonight, David Levy, and another comet hunter, Mr. Shoemaker, Eugene Shoemaker. And the result of this impact was something like 400 or 500 Hiroshimas. This comet slammed into the planet Jupiter. The largest piece, I believe, was about a mile wide, so it's not quite as big as the dinosaur killer, but it was moving at 134,000 miles per hour, and had it hit our planet, it could have wiped out most of our life. That's my understanding of the Shoemaker-Levy comet. But is it really a threat to us? Thank you. Are asteroids a threat? Well, there are a lot of asteroids. There are millions and millions of asteroids, and we track a lot of them that come near our planet. The near-Earth objects, as they are called, number in the thousands. And though we see some pass by in an astronomically near way, we're fairly certain that we're pretty safe. And the reason we're probably not going to have a dinosaur killer is that we believe that the impacts that we see in the solar system have dropped to an all-time low. And that's just because of the way the formation of the solar system went. There was a very heavy period of impacts. They call it the late heavy bombardment. But it's for the most part tapered off. And we don't see that many big impacts anymore. But that doesn't mean we don't attempt to protect ourselves. Last year, Our government established a space force, and among their missions is to protect the planet from near-Earth objects that could be impacting. We have a private effort to preserve what part of our species we can by diversifying the globes we inhabit. But I think one of the biggest things we can do is just appreciate how amazing it is that we're here to even contemplate this stuff. Had that asteroid that wiped out the dinosaurs arrived a few hours earlier or a few hours later, it wouldn't hit that anhydride-rich zone. And it would have been devastating, but it wouldn't have been a dinosaur killer. In fact, there was a bigger asteroid that hit when these creatures that survived for 180 million years. That makes our 2 million years just look like a blink of an eye. Those dinosaurs survived another impact that was bigger, but it didn't hit, so to speak, the sweet spot. It didn't hit that sulfur-rich rock. But had it not hit, had that asteroid been a few hours earlier or a few hours later, it wouldn't have cleared the slate for the mammals to thrive, to hyper-evolve, to produce this thinking primate that mastered fire and that's going on to conquer space. What a thing to appreciate. Thanks for listening. Are there any more questions?
We've got one more from Mary. She writes, is it true the impacts are particular to the time lapse and aging of the solar system, notwithstanding that it will happen again? Not if, but when.
Not if, but when. The future is a hard thing to predict. Will it happen again sometime? I'm inclined to say it might. Will we be around then? Will we still be on this planet? Will we still be around? I don't know. These are questions that do keep scientists that are very interested in this subject up at night, because it's hard to say.
Well, a final question is a little wider than a scientific-only question. Christopher asks, how do you feel about the privatization of space travel and the possibility of colonization efforts on other planets? Do you think that this will lead to space being treated as just another piece of land?
I think that's a good question. I think it's our nature to want to conquer things as if they are possessions. But I think even those who are pursuing that route, say, like Elon Musk, I don't even think I think that's just a modality of the approach rather than the end result. I think the end result is to provide for our species and for the rest of the species on our planet as best we can. And I think the modality of privatization is not only inevitable, but it's a useful modality. Maybe it's not the end-all be-all, but it is certainly one lever we should be pulling to try to save the day, should something like that ever happen again.
Excellent, but we have one more we'll fit in. One
Sure.
more before we finish. Kenneth has a question, a very fascinating question. Are there any ideas on how we could alter the trajectory of a near-Earth asteroid heading our way?
The key to doing that is time, because we don't have yet an energy source large enough that can redirect an asteroid that is nearby and heading our way. If we can detect it when it's very, very far away, we can, over time, get it to move with a small force. We can't generate a force that's large enough to move something that's heading our way that's considerably sized. But if we can buy ourselves enough time, if we detect it more than a few days in advance, like a month in advance or a couple weeks in advance, we perhaps could get out far enough where over that length of time of its approach, we could deflect it. Someday, maybe. I don't think we're there yet. We still have instances where, surprise, there's one that's coming really close in the next 3 days, and we'd have nothing we'd be able to do. So right now is our nascent efforts at protecting the planet, but they get better with each passing decade.
That's a great answer. Yes, we do get better at it, but right now there's not a whole lot we could do. We don't have the time. Well, Jesse, this has been fantastic. Really appreciate it. It was very enlightening, entertaining, fun. We had great questions. We had almost 100 people online.
Wonderful.
And so I thank you for this, and look forward to you next year. You're going to get out there with us, on the beach, right? And you're going to be doing another presentation. I
am so looking forward to it, and I appreciate you asking me to present, Brian.
All right. Well, you have a good evening, and say goodbye to your children, if there are any that are still awake.
I can hear them. I will.
All right. Go ahead.